All right, so when you log into your Blackboard account, so you're gonna click on our class, which is the Calculus 2 section 57. You can see my YouTube channel here for the recorded lecture. So far, I upload the clip from the first day that we had a class together up to homogeneous and exact differential equations. And also you're gonna have integrating factors and linear and Bernoulli differential equation. These two videos, they are optional for this class because the topic that I cover for the exam gonna be just for the first clip up to exact differential equation. So if you have more time and if you want to study more, you can go to indicating factor and linear and Bernoulli differential equations. But for just this week and next week, maybe you need to focus on the topic that will be on the exam first. All right, that is the channel for you to just review everything. Well, some questions on the exam will be similar to the lecture. So well, I guarantee that if you look at the lecture again and again and you can do all questions, you should be able to do the exam easily. All right, so once you log into Blackboard, another thing that you will see is you're gonna see the review final packet here. You can click on it and you're gonna see this is 15 questions that I select to do, to just go over together in class. Well, this is good practice because some questions, yeah, they are good one that it's just a thing that you can review some concepts. Okay, and what else? That is for that's it for Blackboard. Okay, good. All right, so we're gonna come back to our review packet, but before we get started, so let me answer the question in the chat first. So at 10:02 a.m. today, I have a question from Nida. She wants us to look at polar coordinate integration. So we're gonna look at that question first together, and then we're gonna just start doing a review. Well, if you have any question in general, you can just send it to me so we can look at it together. So one question that you may have, like one student asked in class today is just, let's suppose this is example from Nida. So let me translate that thing. Well, let's suppose that you have equation here, which is the circle with radius 2, r equal to 2 here. This is the circle with radius 2. Well, this is a similar thing to x squared plus y squared equal to 4. This is the same thing. R equal to 2, this is the equation for circle in polar coordinates. This is the same thing with x squared plus y squared equal to 4. And also you have the equation r equal to 4 times sine theta. Well, if you think a little bit, so this is going to be a circle with radius 2 as well, but it's lie here. Some of you are gonna say, how do I know that this is a circle there? So, well, you can try switching. R is equal to, you're gonna multiply r to this equation first. So you get r squared equal to 4 times r times sine theta. This is the same thing that I multiply r on both sides. And because I know that r squared is x squared plus y squared and r sine theta is y. So this is going to be x squared plus y squared equal to 4y. And if I simplify, so I'm going to get x squared plus y squared minus 4y equal to 0. And if I simplify one more time, so I'm going to get x squared plus y squared minus 4y plus 4 equal to 4. So I add 4 on both sides. And that means x squared plus y minus 2 squared equal to 2 squared. So technically, this is a circle. Center at x equal to 0, y equal to 2, and radius 2, which means that circle is the blue one in the picture. I equal to 4 times sine theta. Let's suppose that you have these two curves and the question asks you to compute, you know, the area that I shaded in orange here. Outside the red, outside I equal to 2 and inside I equal to 4 times sine theta. How would you do it? For sure, this is clearly that you have to work on polar coordinates, because if you do dx or dy, dx dy or dy dx, it's going to be terrible because, you know, because your equation is going to be x squared plus y squared equal to 4 and x squared plus y minus 2 squared equal to this thing, which is not easy to integrate for sure, because you're going to see that you're going to have the messy term that you have to work with. So working with polar coordinate is a lot better. For sure, when you see circles, polar coordinate going to be your friend. Well, this thing is, you know, well, the question from Nida is, yeah, for sure, we're going to just set up the area to be integral of 1 dA, right? Because if you put 1 in the integrand, that means you get an area. But for polar coordinates, you're going to use r d theta. Well, the question from our friend is, how do you get the boundary of theta? So for sure, when you do the polar coordinates, you're gonna do something like array here. So you're gonna start from the pole and then you keep going that way, just this way, 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 this way. So for sure, you are gonna be your bottom curve. And you can see that every time when you do the ray here over there, so you're gonna get this ray, right? The bottom curve gonna be the red one, which is I equal to 2, and the top one gonna be I equal to 4 times sine theta. Does it make sense? Because every time when you start here, you're gonna get I equal to 2 to that r equal to 4 times sine theta. The question is, what is going to be the range of theta? So how do you know? Well, for sure, you need to solve for the intersection, and then once you get the intersection, that would be your theta. So the intersection here is going to be the point that it is the intersection between, well, let's find the intersection here. This is I equal to 2 and I equal to 4 times sine theta. So you can see that you can find the intersection by looking at 4 sine theta equal to 2, because you equate these two equations, and then you get sine theta equal to 1/2, and that means, well, what are the values that sine theta equal to 1/2? For sure, this is going to be pi over 6, and am I right? Pi over 6, and another one is 5 pi over 6. Well, that is how you find the theta. The bottom theta is pi over 6. The top one is 5 pi over 6. And that is the area. Okay. Let's come back to our review packet then, because this question is just from something outside the class. But let's come back to our review packet here. Anyone have any more questions that is not in our packet here? So you can ask in the chat. Anyone else? Okay. Well, for those of you who are here today for the review, so, well, I want you to type in the chat what topic that you want to review first. So, you know, we probably don't have time to go over our questions. So I want you to pick the one that you think it would be the most beneficial for you. Pick the one that you think that you want to go over in class together. So question 1 to 5, this is from the chapter, the differentiation chapter. Question 6 to 10, that is from integration chapter, and question 11 to 15, that's from differential chapter. So which one do you want to do first? Type in the chat, please, everyone. I will count the vote soon. Well, let me see the chat. Start from here. Shooties and higher chain rule. So we have, well, 1 second. I need to delete that. Let me delete that one first. Well, we're gonna count the vote. We have 1 vote from Shuri, higher chain rules, which is question 5. Okay, 1 vote here. Integration chapter, well, question 6 to 10, 1 vote here. Maybe I'm gonna pick one for you. Maybe question 10, because that is the integration chapter. Differential equation, well, it's 11 to 15, anyone? Maybe 15. Just pick the last one, maybe the last one. Integration, differential equation, higher chain rule. Whoa, seem like the vote are like equally likely. So we're gonna just doing. Okay, let's do each question from each chapter then. So let's start from question 1 to 5. So I'm gonna show you how to do question 5, because this is the chain rule one that use the higher order derivative. This is required. This is the request from Shuri and Dolapon. We're gonna do this first, and then after that we're gonna pick one question from integration. Because Miss Yu and who else? Mark. Well, they wanna do integration, and then lastly we're gonna do differential equation because Nida and Pakawat wanna do it. Okay, so let's do question 5 first. Well, let's do the review here. So we have a function w equal to fxy and x equal to 2u plus 3v and y equal to u times v. Well, I want you to show that this equation is true. Oh no, Pokemon Go. Here what are you going to do is just you need to prove this statement. Well, this is similar to what you're going to see on the exam, because well, I want you to simplify until you get the form that I want. Well, look at this question. This is going to be the one that, well, you probably see on the exam, the similar one, just, but switch the function or something. So first of all, you can see that w is a function of x and y. So when you draw a diagram, so every time when you do the chain rule, you have to draw a diagram, right? So you can think of w as a function of x and y, and then x is a function of u and v, y is a function of u and v. And then once you set up the tree, you can just do the higher order derivative. The hardest part is when you do that, you just need to do the higher order derivative. So you're gonna do differentiate 2 times. All right, so let's do that. 1 second. I think I need the new blank one. All right, so I have w is a function of f x y here, right? So this is question 5. So I have w is a function of x and y, okay? And x is a function of u and v. X is a function of y, function of u and v. Well, let me open the question on here so I don't have to switch over. Okay, I have x equal to 2u plus 3v. And also I have y equal to u times v. Okay. The thing that what we're gonna do first is we're gonna do, well, the question asks us to compute differentiate 2 times with respect to v first and then with respect to u after. So that means you have to differentiate w with respect to v first and then differentiate with respect to u after. This is the meaning of that notation. So we're gonna find the thing here first, the differentiate w with respect to v. All right, okay. Well, again, the same technique as before. The first step, you just see w and v here, and then you can go here. So that means you can do the chain rule, right? It's gonna be differentiate w, or you can say f, the same thing, because the name of the function is f or w. You can use whatever you want. W is correct, f is correct too. It's just the name of the function. So differentiate f with respect to x, and then x with respect to v, and then differentiate f with respect to y, and then y with respect to v. Well, this is complete by using the chain rule, because in order to go to v, you have two ways. So via x and via y. And then because you know that the function of because you know the explicit form of x and y, so you can differentiate x with respect to v, right? This is 3. Differentiate x, differentiate y with respect to v. You know that this is u. So you know these two things, so you can plug in first. So you're gonna get that multiply 3, and then plus that multiply u. Okay, so I just compute differentiate x with respect to v and differentiate y with respect to v, because we know the explicit form. Okay, this is nothing other than you simplify it. And then after that, well, this is the step that is going to get harder. Well, up to this step, everyone should be comfortable to do that. But after this step, this is why Dolapon and Shuri, they want us to go over this question, because, after you differentiate one more time here, the thing gonna get complicated. Because, well, you can see that if you differentiate one more time here, you're gonna get that, right? And then plus that. The thing is that if you think one more time, well, the first step that I should do is I'm gonna just just separate it into two terms. So differentiate u, and then here I'm gonna get differentiate f x times 3 here. This is the first term. The second term is going to be differentiate u, and then curl f by curl y, and then times u. Well, this is nothing other than I expand it. Well, but the thing is that the first term here, number 1 here, you can see that it's a little bit complicated, because even 3 is constant. You can pull number 3 out, but the function inside curl f by curl x, it still depends on you. Well, you don't know that curl f by curl x gonna be what function, but it still depends on you, because this is depend on f, and f is on the top level, so it's depend on you as well. So that means, well, to get it step by step, we're gonna set this thing to be number 1 and set this thing to be number 2. We're gonna just do it separately, and then we're gonna add them up together at the end. So for number 1 here, I'm gonna get 3 times that. Well, this term is a little bit okay, because I can pull out number 3 first, and then after that, well, because this term that I highlight in light blue here, this term depends on you. It depends on you. So that means, well, in order to get to you at the end, well, the term that I highlight in orange, it's still on the top level. So you can go by x. You have two parts to get to you. You can go by x, or you can go by y. So actually, this thing is going to be 3 times. Well, look at that. It's going to be, well, differentiate with respect to x first of that green of that term, and then curl x by curl u, and then plus differentiate with respect to y, curl f by curl y times curl u, curl y by curl u. Well, this is the thing that some of you get confused, and this is the hardest part for this chapter, because some of you have a hard time to understand that. Well, the thing inside here, this is the the thing inside the parenthesis, which is the term that I highlight in light blue here. This is the term that you need to, you know, you can, it's on the top level and you can differentiate with respect to u by going to where x or where y. That is mean I have x here, I have y here, and then separate it. Okay, and then I'm gonna carry this term to the next page. All right. Well, keep in mind, this is kind of similar to what you're gonna see on the example. Okay, here we're gonna just say that this is term number 1. Okay, and then, well, look at that. So you're gonna have 3 times, well, the term that I have here first, well, if you rename it, you're gonna get differentiate 2 times f, differentiate x squared here. Well, this is the notation for that. And then, oh, well, we have differentiate x by u here, which we know the form of x here, so we can differentiate with respect to u, so you get 2, and we know the form of y here, we differentiate with respect to u, so you get v. Okay, keep that in mind, and then you're going to use it later here. So that is number 2, and that is the notation here, and then that is v. Okay, and then this term going to be 6 times that, and then plus 3v times that. Okay, well, this is a term that I got from number 1 here. Well, let's see if you have the hope that it's gonna match with your answer. Ta-da! Because you can see in the question that you have this term already, and you also have that which is, oh no, I mean this term. Well, you should have this term, right? UV. Well, let's see if you have that. Did I do something wrong? Surataya say why the second term you highlight it's f over y. Okay. Oh yeah, sorry. Yeah, Surataya, thank you for correcting my mistake here. So it's x. Sorry, I copied wrong. Sorry. Good. That is why this is x. X, and that is, well, that, well, you can see that I made a mistake, and then I check with the answer in the question, and you see immediately that you have a mistake, and then, whoa, this is good. All right, so you can see that, oh, it matched with the form in the question. So far so good. Well, this is matched with the form in the question. Well, you already have this term and already have this term. Sounds good. Well, this is what I expect for you to, to complete that one. Well, this is a long question. And then number 2 here. Okay, you need that number 2, which is, well, let's do one more term. And then co f by co y, and then times u. Okay, good. This is term number 2 here. And in order to term number 2 here, it's a little bit harder compared to term number 1, because you have 2 terms. This depends on you, and this depends on you too. Well, both of them depend on you. So that means you have to use product rule. Well, it's gonna be keep the term co f by co y, and then you differentiate just u, right? And then keep u, and then differentiate co f by co y. Make sense? Well, this is by the product rule. The product rule for differentiation. And then once you apply the product rule, you can see, oh, okay, differentiate u with respect to u. Here you get 1. This is okay. Well, it's go away, so you have that. Okay. And then good. And then next, I have, what do we have this term in the answer? Let's see. Well, you see you have this term in the answer. So you're getting close. Okay, next. Well, you're gonna do that. You have U, and then, well, again, this term is the term that I circle here. This term depends on U. So that means you have to apply the chain rule for it. So it's gonna be co X times co X by co U. Okay, this is the whole thing. And then plus co Y. Co F by co Y here, and then co Y by co U. Okay. Well, this is by the chain rule again. So if you have a hard time to follow, think of this thing as the thing in orange here. And then when you differentiate, you can, just do that. And then after that, you're gonna get here. So keep going, and then plus U, and then this term gonna be co square F, co X, co Y. And then co X by co U, you already computed. Co X, co U, this is number 2. Right, the same thing as before. And then plus co square F by co Y square, co Y by co U, you already computed. This is V. Okay, simplify it. So you get co F by co Y plus 2U co square F by co X co Y, and then plus UV co square F by co Y square. Looks pretty good to me. So once you add number 1 and number 2 in the box, so you hope that it's gonna come back to what you want in the question. And let's see. Well, it's come back to what you want in the question, right? Because this is box number 1 that you have. And this is box number 2 that you have. Okay. Well, make sure you can do this question. It's gonna be a good candidate for sure for the final exam. And I can change the function here. For different students, you're gonna get different function. Well, you just need to do it by your own. Okay. This is a good question to practice. So actually, it's just the long one. Well, maybe you spend more than 15 minutes for this question, so you have to save another minutes from the easy question. Okay. Okay, this is the question from the chain rule. Do you have any question? The chain rule and higher order derivative, it's gonna be the question like this. Okay, sounds good. Well, if we have time left, we're gonna come back to this thing, but right now I want to move to integration part. Well, you can do question 1 to 5 at home. If you feel like you do not understand or you cannot do it, we're gonna come back and look at it on Friday. Well, on Friday I can't just go for more problems because some of you want to do the critical point 1 or the one. Well, if you have time left, we're gonna come back, but we're gonna just follow the request from student first. I look at the chat and I see Miss Yu and Mark. They want us to do one question on integration, so I'm gonna pick one. Well, you can do 6 to 9 at home first. Well, you can check with me after. Well, let's do number 10 then. Well, we're gonna do this question number 10 first. Well, and see, maybe we're gonna hit 11 a.m. and then we're gonna have a break and then we come back for differential equation, sorry. Okay, let's do number 10. I want you to evaluate the integrals by the method of your choice. Well, this could be the question on the exam that I asked you to integrate, but you just need to pick the method by your own. Question A first. So question A, you can see that I want you to integrate sine y square dy dx, y from x to pi and x from 0 to pi. Well, question A, this is easy. Well, easy in terms of it is clear that what you should do is, well, let's see. What you should do is, you can see that in the integrand here, you have sine y square. If you want to differentiate with respect to y, it's going to be super difficult. It's going to be impossible to differentiate with respect to y because you don't have the formula to integrate sine y squared. Well, for sure, you have to reverse the order of integration. Okay, you have to reverse the order of integration. So you integrate with respect to x first, because if you integrate with respect to x first, sine y squared going to be constant, and you can pull it out and then you just integrate easily. So what we hope is, we hope that we can switch the order of integration sine y squared here to the x dy. Okay. Well, if you can switch the order of integration, the world going to be easier for you, because you can pull out that term sine y squared outside and you will be good to go. Well, the thing is that how do you switch the integration then? Well, I need to draw a picture. So the domain going to be x from 0 to pi, right? And y from x to pi. Well, I got that thing from the question. This is my domain. Well, you're gonna draw a picture first. So the highlight one is going to be y equal to x. I think this is similar to the quiz that you just did, I think. Y equal to x here, gonna be this line. And then x equal to pi here, gonna be this line. And y equal to x here. And then x equal to 0 and x equal to pi over there. Y equal to pi, it's here. Y equal to pi. Okay. Well, seems like you have so many lines over there. You have x equal to y, y equal to pi, x equal to pi, and x equal to 0. X equal to 0 is this line. Well, first of all, you have to figure out which area that you want to integrate with respect to. So my first guess, I think, well, let's look at that. Y start from x to pi. So maybe that means y equal to x gonna be your bottom curve. Well, that means, yeah, I suspect that this thing gonna be our region of integration, because you start from y equal to x and then it's go to y equal to pi, right? Yeah, that is what you want. And then, well, you can see it match that y start from x to pi, and then x start from 0 to pi, which is the domain of x going to be x0 to x equal to pi. Yes. Okay, so the area that we want to integrate with respect to, it's going to be the thing that I highlight in light blue. So now we switch to the x dy, you just do that way. And then it's going to be x from 0. How do you know that is 0? Because here x equal to 0. And then here it's x equal to y. The right curve going to be x equal to y. So that means 0 to y. And then y going to be from 0 to pi. Right? Because you instead of doing the vertical line, you do the horizontal line. So that means good. It's 0 to pi. Well, once you switch the order of integration, well, I'm gonna do it here because it's easy. So you integrate 0 to pi, you pull out sine y squared first, and then you hope that when you integrate dx from 0 to y, you're gonna have something that help you to integrate. Well, you integrate x from 0 to y, so you get y. This thing is a lot easier now, because the term that I highlight in yellow here, well, you integrate, you get y. Well, you integrate dx, you get x, and then y minus 0 is y. Well, now your integration is going to be a lot easier, because you can do a substitution. Well, if you let u equal to y squared and then you integrate it, you're going to get the answer you want. Well, I'm going to skip that part and let you do it by yourself. But if you let u equal to y squared, then we can integrate it. Right? Just from calculus 1, everyone know how to integrate it. Set u to be y squared, and then your y gonna cancel out with du over 2y or something. Just y cancel out, and then you can integrate it. Well, this is the type of question that you probably see on the exam as well. We just switch the order of integration. If you want to practice on switching the x dy dx, this is the question that you should do too. Something like that. Okay. One more question before the break, and then we come back with differential equation on the second hour. Let's do question B. So question B, they ask you to find, to evaluate this thing. First of all, you can see that the question gives you something in terms of dy dx. For sure, you do not want to integrate this term. This is terrible to integrate square root x squared plus y squared. You know, maybe you're gonna use trigonometric substitution or some integration technique that could be terrible for you. But as I told you that when you see x squared plus y squared, this is a good sign that you should use polar coordinates. Because when you see x squared plus y squared, it's gonna be circle. I mean, you know, it's gonna related to circle, and this shouldn't be a problem for doing polar coordinates. So we're gonna do this question by using polar coordinates. So I'm gonna start a new page here. Okay. Oh, so let's do that, and then we have a break then. So question 10b. All right, for those of you who already you know, expert in integration, this is just a review one, so be patient. I know this is super easy for some of you. Okay, here we're gonna just start from looking at the integration here, the integral here. First of all, for sure, we need to draw a picture. Or every time you need to draw a picture, because it's gonna be important that you need to know what area or what region you are integrated with respect to. And then here it's gonna be set of the point x, y such that y between 0 to square root y minus x squared and x from 0 to 3. Okay, this is your domain D. Okay, you're gonna draw a picture first. Y equal to 0 is just, you know, the line here. X equal to 0 is the line here. X equal to 3 is the line here. So, well, we're gonna stop that first. We're gonna just do y equal to square root y minus x squared. Y equal to square root 9 minus x squared. Well, this is the same thing with y squared equal to y minus x squared. And that is x squared plus y squared equal to 9. Actually, this is a circle with radius 3. But, you know, one thing, it is a circle with radius 3, but you just pick the curve that y is positive. So actually, it's going to be just semicircle like that. It just, you know, my scale is not that good. It just looks like a circle now, but because I didn't use a ruler at all, but you know, this is just a draft. Well, this is the circle with radius 3. So I know this is circle with radius 3. Okay. Well, I just picked the curve above the axis because y is positive. And then now you can guess what area you want. So you want y start from 0 to that. So it means actually you draw y from 0 to 9 square root 9 minus x squared, but you want the area x from 0 to 3. So actually it's going to be just this part, the part that you have in the first quadrant. Okay, actually it's just this part in the first quadrant. Well, how do I know? Again, one more time, because, well, once you figure out what area you want to integrate with respect to, you can double check with your question. So the question say y from 0 to square root 9 minus x squared. Yes, that's perfect, right? And x from 0 to 3. Yes, that's good. 0 to 3. Well, this is what I want. But now you're going to switch the order of integration to, well, let's say you want that, 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 you want that. Okay, this is integrate. Okay, square root x squared plus y squared. You switch the x, dy, dx, whatever you have, to r, d theta. All right, this is the thing that you want. And then now you figure out the domain. Okay, r from where to where? So r from start from 0, right? This is the pole. R start from 0, and every time when you draw the, you know, the diagonal layer or something here, every time you're going to hit the circle, well, that means the circle going to be your top curve. The circle is x squared plus y squared equal to 9, which is r squared equal to 3, which is r squared equal to 9, which is r equal to 3. Okay, r equal to 3. And then theta going to be what? So theta going to be 0 to pi over 2. It is clear from the picture that the theta that you use is going to be 0 to pi over 2, right? It's just that. Well, if you have a hard time to think why it is pi over 2, you can, you know, y equal to 0 is your last, x equal to 0 is the stop point for you. So that means you have r sine, you know, x is r cosine, r cosine theta equal to 0. And that means cosine theta equal to 0. And that means theta equal to pi over 2. That is how you solve for theta. But, you know, you can see from the picture, it's 0 to pi over 2 anyway. Okay, and then you, well, one more thing, you can switch this inside to square root r squared, which is just r. Okay, and then you just start from that. Well, a lot easier now. R squared, the theta, you take square root of r squared, you get r, and then you multiply another r, so you get r squared. Then this is r cubed over 3, and then 3, 0, and then integrate 0 pi over 2 d theta. Okay, and that will be well, 3 square is 3 cube. This is 27, and then over 3 you get 9. So that means you get 9 and then times pi over 2. Just integrate it. So the answer is 9 pi over 2. That is your answer. Well, pretty simple and easy when you do polar coordinates. You can see if you do the switching to dx dy, it's going to be terrible because you have to use trigonometric substitution. Okay. We're going to have a break here, 10 minutes, I think, when we come back at 11 a.m. So we're going to do more questions on differential equation chapter, which is a part that some of you have requests for. Okay. Any questions so far? Well, let me look at the chat. Okay, you got it, Trudy? 0 to 3. Okay, good. Yeah, I think you answered my question. Good. 11 to question 11 to 15, we're gonna come back and look at it after the break. Okay. Okay, so let's have 10-minute break. If you have any question, let me know. We're gonna come back at 11 a.m. Bring your question if you have one. Okay. Okay. 10-minute break, everyone. Gonna mute my microphone. So can you type in the chat, give yourself how confident you are for the final exam right now out of 10. So let's see, how would you be, I mean, let's see what score you get out of 5. No way, 7. So you, well, it means you have so many final exam, right? That means you need to have so many things to review, to study. I know this is the, well, it's, yeah, it's the first year student, you know, first year student, you just have so many things to study other than calculus. You have physics, chemistry, and a lot of things, you know. Okay, so we're gonna come back to question 11 to 15 here. This is differential equation. We're gonna look at I think question 11 is easy because it's a separable equation. You can do it by yourself. We're gonna look at one question for homogeneous differential equation, okay, and one question for exact differential equation. Let's do question 12 first because I see that is for sure homogeneous differential equation. So first, show that the given differential equation here is homogeneous, and then show step by step that its general solution is this one. So that means you have to simplify until you get the form I want. So the last form that we want is x squared times 2y squared minus x equal to constant c. Well, that is your solution. You need to start from the beginning, show that this equation is homogeneous, and okay, its general solution gonna be that. Okay. Okay, so let's do number 12 together first. Then I will come back to the chat again. Question. Or if you have anything, leave the question in the chat. So let's do number 12. So what I have here, I have y squared minus, oops, sorry, x squared dx minus xy dy equal to 0. You know what? Even I don't say that this is the homogeneous differential equation, you are supposed to know it by yourself, because you can see that this question is not separable equation, because you have x and y here. No way you, in terms of y squared and x squared, you cannot separate it into the product of function of x and function of y. So that means at the end, this is not differential. This is not separable equation. So you cannot say this is the separable equation. Well, the first thing that we're gonna do here is we're gonna look at the question, and the question said that first show that the given differential equation is homogeneous. That's the first thing you need to do it. Number two is you show that the general solution is that. Okay, we're gonna show that the function is homogeneous, and then after that a differential equation is homogeneous, and then after that you're gonna solve the equation. Okay, yes, Nida asked in the chat that do we have to prove that this is homogeneous? Yes. Well, if you skip that step, yeah, I mean, you will not get a full credit on the final exam. So, well, let's do that. You have your function m here, your function n here. So before go further to the next step, so let m to be y squared minus x squared. Well, you can see that m is homogeneous of degree 2, because if you add tx ty, well, you replace the x dy here, so you get ty square minus tx square here, and then you get t square y square minus x square. Well, this is t square times mxy, so this is good. This is actually m is homogeneous of degree 2. Okay. And your n here gonna be xy. Well, this is super easy function. I let n to be xy, so then n tx ty. So this is going to be tx times ty, which is t square mxy, nxy. So this is actually also n is homogeneous of degree 2. Okay. Well, you got it. M and n are both homogeneous with the same degree. Well, because m and n are homogeneous of the same degree. M x y. Well, I just write the whole thing, but you can just make it short. This differential equation is homogeneous. Okay, good. And then after that, once you know that the differential equation is homogeneous, okay, it's time to solve it. Well, as you know from the class that it's going to be long, but well, you have to do it. So the first step, check that the equation is homogeneous. The second step, you let y equal to vx, right? This is the step that you need to set up. So you let y equal to vx, and then if you differentiate y, so you're going to get v dx plus x dv. Well, this is the important step for homogeneous differential equation, and you should memorize that, or jot it down, because you have to use it on the exam as well. And then you plug in dy to the original equation, and you hope everything gonna turn to separable equation. So I plug in, well, we're gonna just plug in that and that into that and that and that in the original equation. Okay, so we're gonna do vx squared minus x squared dx, and then plus x vx, and then dy is v dx plus x dv equal to 0. Well, this is guaranteed that this is a separable equation, but all you need to simplify it. So v square x square minus x square dx. Well, go slow step by step, because you know you can make a mistake easily on this step because it's so messy now. So you just need to go slow for this thing. So I multiply that, so I get v square x square dx, and I get vx cubed dv. Oh, it looks similar to the example in class, huh? Well, we're gonna expand that thing first because I want cancellation. Do they cancel? Do they cancel, or I did something wrong? Let's see. Well, they do not cancel, right? Because you have v square x square 2 times. But seems like we still have a hope, because we're gonna move everything in terms of x to one side. We're gonna move everything in terms of, I don't see dv. Okay, just do it long. Okay, dv equal to 0. I'm gonna move everything in terms of v to another side, and then hopefully that's gonna be a good one to integrate. I'm not sure this is similar to the example in class, because I feel like this is, I'm so familiar with this question. Maybe it's the question in class already. Well, I'm gonna just group the first term to get 2v squared x squared dx, and then minus x squared dx, and then I'm gonna move that negative vx cubed dv on the right hand side, just move it to another side. So now I'm gonna move everything in terms of x to one side, everything in terms of v to one side. So on the first, on the left hand side, I can pull out 2v squared minus 1 x squared dx, right? Because this thing is because I can pull out x squared dx from both terms, so I get that. And then on the right hand side, I get negative vx cubed dv. Well, I'm gonna just move x to left hand side, so I have 1 over x dx. Well, this is from that x squared and x cubed, just group it together. And then on the right hand side, I have negative v dv over 2v squared minus 1. Well, clearly left hand side no v, right hand side no x, so integrate log absolute x plus c 1. Well, I'm gonna move the negative side to the left hand side because I hate it. Okay, negative side to left hand side and move it to left hand side. And then, well, on the right hand side, if you integrate very fast, so you're gonna get v over 2v squared minus 1, and then I change it to dv to this thing, d 2v squared minus 1. This is 4v, and then that cancel out. So I get 1 over 4 log absolute 2v squared minus 1 plus c2. Well, the thing that is that some of you are gonna say, Ajahn, I do not understand what you did here. Well, that is your problem from Cal 1. So you need to know how to integrate this thing. This is just choose you to be 2v squared plus 1, and you integrate it. Just a basic substitution. You cannot forget this thing, because this is the basic thing from Cal 1. You just do substitution and then you integrate. You don't have to write it. Well, quick as me, you can just set up u equal to 2v squared minus 1 and just do step by step. But you know, at the end, you're gonna get the same answer with me. And then after that, you're gonna simplify a little bit. So now I'm gonna move everything to the one side. So I'm gonna have 1 over 4 log square root 2v squared minus 1. Well, I'm gonna move that Well, I'm gonna move 1 second. I'm gonna move the term on the left here to that right hand side. So the sign gonna be positive both terms. So I'm gonna get plus log absolute x. And then all constant C1 and C2 here, I'm gonna just group it on another side. This thing, I'm gonna group it on one side here. You know, just simplify it. So you're gonna get that. Well, this is my general solution. Okay, now we're gonna simplify until we get the form. The question one, the form you get x squared times 2y squared minus x squared equal to c. So you're gonna use the logarithm property. Do you know how to do that? Logarithm property. So first of all, we're gonna let's see what we should do here first. We're gonna let's see. The first thing what are we going to do is we're gonna multiply number 4 to the equation. So I get log 2v squared minus 1 plus 4 times log x equal to c. Well, basically it's gonna be 4c on the right hand side, but I rename it as c, so you can say that. And then now 4 log x is going to be log x to the 4th power. All right. So I drop absolute now because everything is positive. Suppose everything is positive. And then that is well, log of something plus log of something. This is the log of product, the basic logarithm property. Okay. And that's mean you're gonna get 2v squared minus 1 times x to the 4th power. This is equal to e to the constant, which is another constant. Well, if you want this is to be c, you can say that is 4c. That is 4c. That is 4c. This is e to the 4c, and you can call another c star here. Well, the constant on the right hand side, you don't have to be worried because anyway it's gonna be just constant. And then after that, when you replace v by, well, because you do a substitution first, that y equal to vx, so v equal to y over x, so you can use it here. Okay, long way this question, and then you get 2 times y squared over x squared minus 1, and then multiply x to the 4th power equal to constant. And then that means you multiply x squared to the equation. Oh no, sorry, you expand x to the 4th power inside the parentheses. So you get 2x squared y squared minus x to the 4th power equal to constant c, and then you pull out x squared. All right, you get what you want. You know, just simplify into the form that the question want you to answer. Leave it in this form, and then that will be your answer. Well, again, this question is long, but it is not that hard. It's just long. It's long, but it's not that hard. Okay, so for homogeneous differential equation, I hope you feel better about this topic, because as long as you check the question is homogeneous, you do a substitution, equation gonna turn to separable equation, you integrate, get the answer. Long one, but you can do it. This is just, it is the same thing with driving a car. If you know how to drive, you can do it. It just, well, there's nothing fancy about this topic. So if you want to practice on homogeneous differential equation, you have another question. Question 13 is also homogeneous differential equation. You can do it. If you want more, you can Google it. Just Google the word homogeneous differential equation. It's gonna be everywhere in the internet. That, yeah, homogeneous differential equation is this. You can do it. But you know, it's gonna be waste of time if you keep doing it. if you do like 3 or 4 problems and you feel like, hey, you can do it, it's just like that, you know. This is just the homogeneous differential equation is just a pattern. If you know the pattern, you can do it. It just, you know, at the end, it's gonna be your integration skill. It's gonna be your simplification skill that you just need to do it, work for it. Okay. Well, we're gonna do exact differential equation, one more question, and that is all for today. So if you have any question, let me know in the chat, please. I have a direct message from some student. Some students asked me if I had a solution for this thing. You know, we're gonna go over it again on Friday for the remaining question. But to get it fast, you need to do it by yourself first and compare to me. Because, you know, if you want me to go over everything, I may not have time to go over everything. Well, you can do it by yourself, and the question that you do not, you know, the question that you are not sure, let's say the question that you are not sure, you can ask me to go over it in class together so you can double check the answer. Okay. The next question that we're gonna do is going to be exact differential equation. Well, but no integrating factor, no worries. Yeah, surely no integrating factor, so you could, it's just exact differential equation. This is the last topic that we do for the final exam. Questions? Okay. All right. No questions. Good. All right. Oh, well, if you don't have any question, I don't know you are confused or not. So if you need anything, let me know. Then the last two questions, number 14 and 15, this is going to be the one that I asked you to solve the differential equation, and it is exact differential equation. Well, let's review how to do it. So pick the one you want, 14 or 15. Okay, answer me in the chat. Do you want us to do number 14 or 15 together? This is the last one for today. 14 or 15. Okay, should we say 15? Everyone agree? No participation? 15. I know your brain just need a break, huh? Well, answer me in the chat, 14 or 15 you want? Okay, Nida said 15. 15. 15. Punawat said 15. Natikiat 15. Okay, well, maybe we're gonna do 15. It looks harder, right? Number 15, because you have initial condition as well. So we're gonna do number 15 then. And then you do 14 by yourself. And if you want to compare with my answer, bring it on Friday so we can check the answer together. Okay. Also, okay, seems like everyone gonna say 15, which is good. Okay, we're gonna do number 15 together in class then. Well, for those of you who answer in class, regularly, I remember your name, I remember your name. Good. Well, I know that you participate, and well, if you are on the boundary, like if you get 79 or 69, something like that, well, I will just, put you to the next level, and you should get a good grade for sure. Well, I remember your name. Well, everyone who answered me regularly in the class from the first day up to today. Okay, number 15, solve the initial value problems. So we're gonna solve this equation. Okay, let's do this question. So they didn't, well, the question didn't state that this is the exact differential equation, but you should be able to verify by yourself, right? You can see that this is no way to be separable equation because you have x plus y squared. Seem like impossible to be differential separable equation. It looks complicated. For homogeneous differential equation, this is my m, this is my n. Well, if I try to check the homogeneous differential equation, it will not work. You can try. It will not work. The form is just too hard to use homogeneous, too complicated to use differential equation, homogeneous technique. We're gonna do number 15 by set this to be M. Sorry, this must be M. This must be N. And then we hope that exact differential equation gonna be a good way to do it. Okay. Well, stay with me. I need about 15 to 20 minutes, and then you're good to go for today. All right. We're gonna let M to be, let's say, in the question. What is that again? One more time. Sorry. I think I need to carry the negative side too, because this thing is the term that equipped with X and equipped with Y, dy. I have the yellow one here. So I'm gonna copy that to M and N. So M gonna be negative Y minus 4 over X squared, and N gonna be X plus Y squared over XY squared. Okay, this is from the question. Well, if you wanna check that the differential equation is exact, so we need to check M subscript Y and N subscript X. If they are equal to each other, this is exact. So we're gonna differentiate M with respect to Y first. So you differentiate this thing with respect to Y. Okay, what do you get? For sure, X squared is constant. So you pull out X squared. You differentiate negative Y. What do you get? Negative 1, right? And then plus 0 here, because you differentiate with respect to Y. So that means you get negative 1 minus X squared. This is M subscript Y. Hopefully, when we do N subscript X, you get the same thing. Okay, differentiate X. That. Well, to just make it easy, I'm gonna just separate it in two terms. So I'm gonna get X over XY squared plus Y squared over XY squared. So we are smart. We are not going to just use the quotient rule because it's so terrible. I hate quotient rule. So 1 over Y squared and then plus 1 over X. Oh, wow, this is a lot better, right? After you simplify it, because better than quotient rule for sure. So differentiate that, you get 0 because you differentiate with respect to X, and differentiate 1 over X, you get negative 1 over X squared. Absolutely amazing. So you get the same thing. Yes, this is what we want. So the differential equation is exact. It is not hard at all, you see. Yeah, differential equation is exact. Well, if you know how to differentiate, well, check it. Differential equation is exact. Now the second step is, after you know that this differential equation is exact, so the general solution of this differential equation, or I should say a general solution of this differential equation is fxy equals c. So this is the agreement or our terminology that, well, if you know that the differential equation is exact, they're going to be a total differential that is matched with the form of the differential equation, and the answer is going to be fxy equal to c. You need to find that f. Well, we're going to find that f where you know that your f, if you differentiate function f here with respect to y, you're going to get x first. Differentiate x with function f with respect to x, you're going to get m, and differentiate f with respect to y, you're going to get n. Well, again, I will use the same technique as we discussed in class. So if I want fxy, well, why not? I'm going to integrate m with respect to x. So it gives me back my function f. Well, but do not forget to add a constant term in terms of y. So I'm gonna just integrate m here. Oh, looks terrible, but well, we can do it. Well, again, to integrate this thing, so don't freak out. Well, first of all, try to pull out everything that is a constant first. Well, you differentiate with respect to x, right? I'm going to pull out negative y minus 4 here because this is just a constant. Here I have that. Okay, feel better, right? Because you just pull out the constant out first, and then after that you integrate that. So negative y minus 4, integrate 1 over x squared, so you get negative 1 over x. Well, maybe it's too fast for you, but you can try integrate that to get negative 1 over x by switching x to the negative 2, and then you integrate x to the negative 2, so you get x to the negative 1 over negative 1, which is the same thing with negative 1 over x. This is the skill from Cal 1 that you need to integrate. And then plus some constant, but constant here going to be a function of y. Keep in mind that on this step, constant going to be a function of y. The reason is because you integrate with respect to x. Now you, in your world, y is constant, so the function here going to be a constant is going to be a function of y. So once you get that, so you're gonna differentiate that again with respect to differentiate that function f again with respect to y, and hopefully you can find that constant hy. Okay, we're gonna carry that to the next page. So on the previous step, we have fxy equal to negative y minus 4 negative 1 over x plus some constant. Well, if you want to be, just want it to be more clean, so I can say this is just y minus 4 times 1 over x, hy, right? And then this is y over x minus 4 over x plus some constant. All right, after I simplify, I get that. Well, but we know that if you differentiate f with respect to y, you also get n. So why not? So we're going to differentiate this thing with respect to y. So differentiate the function I have with respect to y. So you get 1 over x, you get 0, and then you get h prime y. Okay. Well, at the end, you get 1 plus x plus h times y, h prime y. Well, but this thing must be n. This thing must be n. So that means, well, where's your n? It just, your n is over there, which is the same thing with here. So your n is just 1 over x plus 1 plus 1 over y squared. Here, 1 over y squared plus 1 over x equal to 1 over x plus h prime y. Okay, you know that the thing that you have h prime y, that term is just 1 over y squared. And then once you reverse it back, so your hy is going to be the function that you integrate, and then you get 1 over differentiate, you get 1 over y squared. So that means you integrate it back. This thing going to be integrated in one dimension, so you don't need anything other than just integrate it. You get negative 1 over y plus c. Again, this is just a skill from Cal 1. So what, integrate y to the negative 2, you get y to the negative 1 over negative 1. Well, for you, it's going to take time to do that. So take your time, don't go too fast. Well, when I did in class, I can do fast because I know how to do it, because I do this thing so many times, more than 100 times. So it's look like it's easy to me, but when you do it, don't freak out. Why is it so hard for you? It's pretty normal because you are a student. This is your first or second time you start doing it. It's going to take time. When I was a kid like you, I spent 20 minutes per one question because it's just super terrible to just get started. But don't give up. This is not that hard. And then, well, once you get hy, you get back to fxy here. And then you get y over x minus 4 over x minus 1 over y, and then plus some constant. Well, you do not need to be worried about the constant because it's going to group it just another constant. You can call it C as well. Okay, you have everything you want here. So the general solution is y over x minus 4 over x minus 1 over y equal to some constant C. Well, because that constant C going to group with another constant, and then you get C on the right hand side. Well, this question also asks you to solve for particular solution, because they ask you to solve when y -2 equal to 1. So this means when x equal to -2, y equal to 1. Well, that means before we know that the general solution that we have, before we have y over x minus 4 over x minus 1 over y equal to some constant C. This is from the slide that we just did. You can plug in when x equal to -2, y equal to 1. Okay, y equal to 1 here, and then you can solve for C. This is -1/2 plus 2 minus 1 equal to C. So that means C equal to 1/2. Well, that means the solution that you want, a particular solution or specific solution, is y over x minus 4 over x minus 1 over y equal to 1/2. Well, you can solve for C if you have the initial condition here. Make sense?